In this video, we're going to focus on integration. We're going to cover some basic integration rules. We're going to talk about how to find the area under the curve using Riemann sums, the left endpoints, the right endpoints, the midpoint rule, the trapezoidal rule. We're also going to talk about the difference between a definite integral and an indefinite integral. We'll go over properties of definite integrals, and also how to calculate the area using geometric figures or geometric shapes. And we'll talk about the fundamental theorem of calculus and go over a few particle motion problems. So let's begin. What is the antiderivative of x squared dx? How can we find the answers to this problem? What would you do? Well, to understand integration, you need to understand differentiation. What is the derivative of x cubed? To find the derivative of x cubed, you need to take the 3, move it to the front using the power rule, and subtract the 3 by 1. So it's going to be 3x squared. That's how you find the derivative of a function using the power rule. To find the antiderivative, or the integral of the function, you need to add 1 to the exponent. 2 plus 1 is 3, and then divide by this number. 3 divided by 3 is 1. So you get the original expression x cubed, plus a constant c. The derivative of any constant is 0. So this is the antiderivative. If you differentiate x cubed plus c, you're going to get 3x squared. And the antiderivative of 3x squared will give you x cubed. So integration is the opposite of differentiation. To find the antiderivative of x squared, simply add 1 to the exponent. 2 plus 1 is 3, and then divide by that number. So it's 1/3 x cubed plus c. Now let's work on some more examples. Try these. Go ahead and find the antiderivative of x to the 4th dx. 4x to the 7 dx. And 1/3 x to the 8 dx. Feel free to pause the video and work on these examples. So for the first one, we need to add 1 to the exponent. 4 plus 1 is 5, and divide by the number. So you can write it as 1/5 x to the 5th power plus c. Now for the next one, it's going to be 4, and then add 1 to 7, that's 8, then divide by 8. So if you see a constant in front, just rewrite it. Now 4 divided by 8 can be reduced to 1/2. So it's 1/2 x to the 8 plus c. Now for the next one, it's going to be 1/3 x to the 9 divided by 9. Now we can multiply 3 and 9, which is 27. So it's 1/27 x to the 9 plus c. As you can see, these problems, they're not that difficult. Now, what is the antiderivative of 3x? Go ahead and try this one. Now, if you see an x variable, there is an invisible one. That's the exponent. So we could use the same power rule. It's going to be 3x to the 2nd power divided by 2 plus c. Now, what if we have a constant? What is the antiderivative of 5 dx? The derivative of what function is 5? The derivative of 5x is 5, so the antiderivative of 5 is 5x plus c. So using the power rule, here's what you can do. 5 is the same as 5x to the 0. Anything raised to the 0 power is 1, so x to the 0 is 1. Now if you use the power rule, it's going to be 5x to the 1st power. You got to add 1 to 0, then divide by 1. So it works the same way. So what if there's 2 terms instead of 1? For instance, what is the antiderivative of 4x minus 7. In this case, simply find the answer one step at a time. The antiderivative of 4x to the first power is 4x squared divided by 2, and the antiderivative of a constant, like negative 7, is simply negative 7x. And then simplify. 4 divided by 2 is 2. So it's 2x squared minus 7x plus c. And so this is the answer. Now, what is the antiderivative of pi dx? What do you think the answer is going to be? Now, pi is a constant, so it's simply pi times x plus c. Now, what about this one? What if we have three terms? What is the antiderivative of 4x cubed minus 8x plus 6? So if you have a polynomial, simply integrate each part of the polynomial one step at a time. The antiderivative of x cubed is x to the 4th divided by 4 times the 4 in front. So 4 divided by 4 is 1. The antiderivative of 8x is 8x squared divided by 2, and whenever you have a constant, simply add an x to it. So this is going to be x to the 4th power. 8 divided by 2 is 4. So minus 4x squared plus 6x plus c. Now, what would you do if you were given an expression that looks like this? What is the antiderivative of 2x minus 3 times 3x plus 1? Go ahead and try this example. In a situation like this, before you find the antiderivative, FOIL the two binomials. 2x times 3x is 6x squared. And then 2x times 1, that's 2x. Negative 3 times 3x is negative 9x. And finally, negative 3 times 1 is negative 3. Now, before we integrate, let's combine like terms. (2x minus 9x is negative 7x. And now we can find the antiderivative. So it's going to be 6x cubed divided by 3 minus 7x squared divided by 2 minus 3x plus c. And then simplify. So the final answer is 6 divided by 3 is 2, so it's 2x cubed minus 7 over 2 x squared minus 3x plus c. Try this one. Go ahead and find the antiderivative of 4x to the 5th power plus 8x to the 4th power plus 6x cubed divided by 2x squared. So what do you think we should do in this situation? If you have a fraction with only one term in the denominator, separate it into 3 smaller fractions. Divide everything in the numerator by 2x squared. So it's going to be 4x to the 5th power divided by 2x squared. 8x to the 4th power divided by the same thing, and 6x cubed divided by 2x squared. Now, before you integrate it, reduce it. So what's 4x to the 5th power divided by 2x squared? 4 divided by 2 is 2, and x to the 5th divided by x squared is x cubed. Whenever you divide by a common base, subtract the exponents. 5 minus 2 is 3. Now 8 divided by 2 is 4, and 4 minus 2 is 2. 6 divided by 2 is 3, and 3 minus 2 is 1. So this is the same expression in its reduced form. So now at this point, we can find the antiderivative. So this is going to be 2x to the 4th power divided by 4 plus 4x to the 3rd power divided by 3 plus 3x to the 2nd power divided by 2 plus c. So that reduces to 1/2 x to the 4th plus 4 over 3 x cubed plus 3 over 2 x squared plus c. So this is the answer to this problem. Go ahead and find the antiderivative of 3x plus 2 raised to the 2nd power. So feel free to pause the video and try this example. So if you see an expression like this, what you should do is multiply or FOIL 3x plus 2 times 3x plus 2. 3x plus 2 squared is the same as this expression. You have two 3x plus 2's multiplied to each other. So if we FOIL it, 3x times 3x is 9x squared. And then 3x times 2, that's 6x. And also, 2 times 3x is also 6x. And 2 times 2 is 4. So don't forget to combine like terms. So looking for the antiderivative of 9x squared plus 12x plus 4. And that's going to be 9x cubed divided by 3 plus 12x squared divided by 2 plus 4x plus c. 9 divided by 3 is 3. 12 divided by 2 is 6. So this is going to be the final answer. What about a radical function, like the square root of x? What's the antiderivative of this function? So first, let's rewrite it. X is the same as x to the 1st power. And what is the index number inside the square root? If there's no number, if you don't see it, it's invisible too. So this is the same as x, 1 over 2. So what is the antiderivative of x to the 1/2? Well, we know we have to add 1. 1/2 plus 1 is the same as 1/2 plus 2 over 2, which is equal to 3 over 2. So this is going to be x raised to the 3 over 2 power divided by 3 over 2, which when you divide it by 3 over 2, it's the same as multiplying it by the reciprocal, 2 over 3. So it's 2 over 3 x to the 3 over 2 plus c. So this is the answer. So now that you know how to do that, try this one. Go ahead and find the 5th root of x cubed, dx. So let's begin by rewriting the function. So it's x raised to the 3 over 5. And now let's add 1. 3 over 5 plus 1 is the same as 3 over 5 plus 5 divided by 5, which is 8 over 5. So this is going to be x raised to the 8 over 5 divided by 8 over 5, or 5 over 8 times x to the 8 over 5 plus c. Let's try one more radical example. Let's try the 7th root of x to the 4th dx. So first we need to rewrite it. This is going to be 4 over 7 dx. And now let's integrate it. Let's add 1 to 4 over 7. And since the denominator is 7, we're going to replace 1 with 7 over 7. 4 plus 7 is equal to 11. So the antiderivative is going to be x to the 11 over 7 divided by 11 over 7, or 7 over 11 x to the 11 over 7 plus c. And so here's the answer. Now, what is the antiderivative of e to the x? You know that the derivative of e to the x is e to the x. So the antiderivative is e to the x, but plus the constant c, the constant of integration. Now, what is the derivative of e to the 2x? The derivative of e to the 2x is going to be e to the 2x times the derivative of 2x, which is 2, based on a chain rule. The derivative, let's say, of e to the 3x is going to be e to the 3x times the derivative of 3x, which is 3. And let's do one more example so you can see a pattern. The derivative of e to the 4x plus 7 is going to be e to the 4x plus 7 times the derivative of 4x plus 7, which is 4. So now, what do you think the antiderivative of e to the 2x will be equal to? So it's going to be the same thing, e to the 2x, but it's not going to be multiplied by 2. Instead, it's divided by 2. Because if you were to differentiate the result that you have, notice what's going to happen. So let's move the 1/2 to the front. So we have 1/2, and then the derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2. The derivative of the constant is 0, so we could ignore that. 1/2 times 2 is 1, so you get the original answer, e to the 2x. So you need to divide it by 2. So go ahead and try these. Find the antiderivative of e to the 4x dx, and also e to the 5x minus 2 dx. So for the first one, it's going to be the same thing, e to the 4x divided by the derivative of 4x, which is 4, and then plus the constant of integration. For the next one, it's going to be e to the 5x minus 2 divided by the derivative of 5x minus 2, which is 5, plus c. Now, there are some limitations to this technique. For instance, do you know what the derivative of e to the x squared will be? Now, it's not going to equal e to the x squared divided by the derivative of x squared, which is 2x. Because if you were to take the derivative of this expression, you would have to use a quotient rule, and it's not going to give you what you started with. So here's how you can know if that technique is going to work. When you differentiate x squared, or whatever function is here, if you get a variable, it's not going to work. If you get a constant in the bottom, then you could use it, it will work. You'll see that rule is going to be applied to other situations as well. But now let's move on. What is the antiderivative of 1 over x dx? Now you might be thinking of this. Actually, before we do that, what is the antiderivative of 1 over x squared dx? Let's go over this one first. We'll get back to 1 over x. To do this, you need to rewrite the expression. If you move the variable from the bottom to the top, the 2 is going to change to negative 2. And that's what you want to do. And now you can use the power rule. Negative 2 plus 1 is negative 1, and then divide by negative 1. And then rewrite it. This is the same as negative 1 over x plus c. So this is the answer. Let's try a few more examples. Find the antiderivative of 1 over x cubed. So let's begin by rewriting it. This is x to the minus 3 dx. Negative 3 plus 1 is negative 2. Once you integrate it, the integration symbol has to disappear. So it's x to the negative 2 divided by negative 2 plus c, which you can rewrite it as 1, negative 1 over 2x squared plus c. So this is the answer. Now what about, let's say 6 over x to the 4th dx. Try that one. So rewrite it. This is 6x to the negative 4, and then integrate. So let's add 1. Negative 4 plus 1 is negative 3, and then we'll divide by negative 3. So 6 divided by negative 3 is negative 2. So we have this. Now we need to move the x variable from the top to the bottom. So this is going to be negative 2 over x cubed plus c. So this is the answer. Now let's find the antiderivative of 1 over x dx. So you might be thinking of doing this. If you move the x from the bottom to the top, it's going to be x to the minus 1. And if you add 1, negative 1 plus 1 is 0. X to the 0 divided by 0 is undefined. And it turns out that this is not the answer. Now you know the answer already. You've seen it in derivatives. The derivative of one function is equal to 1 over x. The derivative of ln x is 1 divided by x. So this is the natural log of x plus c. And that's something you just have to know. So therefore, what is the antiderivative of 3 divided by x? In this case, this is simply 3 times ln x plus c. Now what is the antiderivative of 1 over x plus 2? This is going to be ln x plus 2 plus c. By the way, if you need to differentiate a natural log function, here's the equation. The derivative of, let's say, the natural log of some variable u, it's going to be u prime divided by u. So let's say if we want to differentiate ln x plus 2, the derivative of the inside, which is u prime, the derivative of x plus 2 is 1, divided by u, which is whatever is on the inside, and that's x plus 2. So you get what you started with. So what is the antiderivative of the following functions? Let's say 1 over x plus 4 dx, 3x minus 3, actually let's say x minus 5 dx, and 1 over 2x plus 1 dx. Try those. So the integration of 1 over x plus 4 is going to be ln x plus 4 plus c. The purpose of having the absolute value is because you can have a negative inside a natural log. So the absolute value will make everything positive on the inside. Now what about the second one? This is going to be 3 times the natural log of x minus 5 plus c. Now the last one, whatever's on the bottom is going to be on the inside of the natural log. So it's going to be ln 2x plus 1. Now notice that the derivative of x plus 4 is 1. So you need to divide this by 1, which won't change the answer. The derivative of x minus 5 is 1. However, the derivative of 2x plus 1 is not 1. The derivative of 2x is 2. So you need to divide this answer by 2. So now let's prove it that we need to do that. Let's differentiate this expression. Let's ignore the c. So the u variable is what's on the inside. That's 2x plus 1. Which means that u prime, the derivative of u, is simply 2. Now anytime you have a natural log expression, it's going to be u prime over u. So we have this constant in front. So it's 1/2 times u prime, which is 2, divided by u, and that's 2x plus 1. 2 times 1/2 is basically 1, so you get 1 over 2x plus 1, which is what we're starting with. So knowing that, go ahead and integrate the following functions. And let's add one more. Okay, go ahead and try these 3. So for the first one, it's going to be the natural log of 3x plus 1, and then the derivative of 3x plus 1 is 3. So we're going to divide by 3 or simply multiply by 1/3. And so this is the answer. Now for the next one, it's going to be the natural log of what you see on the bottom. In that case, that's 5 minus x. The derivative of 5 minus x is -1. So if you divide it by -1, it's just the same as putting a negative on the outside. Plus c. Now for the last one, it's going to be the natural log of 3 minus 2x. Now we have a constant in the front, so we're going to rewrite it. And then the derivative of 3 minus 2x is -2x. So then the final answer for that expression, +4 divided by -2 is -2, and then natural log 3 minus 2x plus c. So this is the answer. So it's time for a mixed review. Go ahead and integrate the following expression. Let's say if you have 7 divided by x plus e to the 4x plus 3 plus the 5th root of x to the 9. So we know the antiderivative of 1 over x is ln x. So 7 over x is going to be 7 times ln x. For the exponential function, it's going to be the same thing, divided by the derivative of 4x plus 3, which is 4. Now the 5th root of x to the 9 is x to the 9 over 5. If we add 1 to the exponent, 9 over 5 plus 1, or 9 over 5 plus 5 over 5, is 14 over 5. Now instead of dividing by 14 over 5, we're going to multiply by the reciprocal, 5 over 14. So it's 5 over 14x to the 14 over 5. And then finally, plus c. Let's try one more. So let's say if we have the integration of 3 over x to the 4th minus e to the 3x plus 2 over 5 minus 4x. So for the first expression, we need to rewrite it. This is going to be 3x to the -4. So we get to add 1, -4 plus 1 is -3, and then divided by -3. So this is -1 x to the -3, which is -1 over x cubed. So that's the first part. Now the antiderivative of e to the 3x, that's going to be e to the 3x divided by 3. And for the last one, it's going to be ln 5 minus 4x. Now we have a 2 in front, and then divided by the derivative of 5 minus 4x, which is negative 4. So the final answer is negative 1 over x cubed minus 1 over 3 e to the 3x. 2 divided by negative 4 is negative 2, and then times the natural log of 5 minus 4x plus c. So that's the answer. Now let's move on to our next example. Let's go over the integration of trigonometric functions. Now, what is the antiderivative of cosine x dx? What's the answer? The derivative of what function is cosine? It turns out that the derivative of sine x is cosine x. So therefore, the antiderivative of cosine is sine x plus c. So if that's the case, what is the antiderivative of cosine 2x? The antiderivative of cosine 2x is going to be sine 2x divided by the derivative of 2x, which is 2. Now remember, make sure that this is a constant. If it's a variable, it's not going to work. So plus c. If you differentiate sine 2x, it's going to be cosine 2x times 2. That second 2 will cancel this one. So therefore, the antiderivative, let's say, of cosine 3x, it's going to be sine 3x divided by 3 plus c. Now, what is the antiderivative of sine x? The derivative of cosine is negative sine. So the derivative of negative cosine is positive sine. So the antiderivative of positive sine is negative cosine. So what is the antiderivative of sine 3x minus 7? So this is going to be negative cosine. The inside part is going to remain the same. So that's 3x minus 7. And then divided by the derivative of 3x minus 7, which is 3. So this is the answer. Now, what is the antiderivative of secant squared 4x? The derivative of what function is secant squared? The derivative of tangent is secant squared. So the antiderivative of secant squared is going to be tangent. Now the angle is going to remain the same. Since we have 4x inside of secant squared, there's going to be a 4x inside of tangent. The derivative of 4x is 4. So let's divide it by 4 plus c. Now what is the antiderivative of cosecant squared 5x? The derivative of cotangent is negative cosecant squared. So the antiderivative of positive cosecant squared is negative cotangent. But it's going to be cotangent 5x, and the derivative of 5x is 5 plus c. Now what is the antiderivative of secant 3x tangent 3x? So the derivative of what function is secant tangent? The derivative of secant is secant tan. So the antiderivative of secant tan is secant. So this is going to be positive secant 3x divided by 3 plus c. So what is the antiderivative of, let's say, cosecant 2x cotangent 2x? The derivative of cosecant is negative cosecant cotan. So the antiderivative of positive cosecant cotan is negative cosecant 2x plus c, and also divided by 2. So let's try some more examples. Go ahead and integrate this expression. What is the antiderivative of 4 cosine x minus 7 sine x? The antiderivative of cosine is sine, and the derivative of x is 1, so sine x over 1, or just sine. Now we do have a 4 in front, so we need to rewrite that. So it's going to be 4 sine x. The antiderivative of sine is negative cosine, but multiplied by negative 7, so that's going to be positive 7. So the answer is 4 sine x plus 7 cosine x plus the constant of integration. Try this one. Find the antiderivative of secant x times secant x plus tangent x dx. So what do you think we need to do in this problem? What we should do is distribute secant. Secant times secant is secant squared. And secant times tangent is simply secant tangent. We know the antiderivative of secant squared. That's tangent x. And the antiderivative of secant tan is secant x plus c. And so this is the answer. Now what is the antiderivative of 1 plus tangent squared y dy? So what can we do here? The antiderivative of 1 dy is just y. But the antiderivative of tangent squared, we don't have an expression for that. However, 1 plus tan squared is an identity. 1 plus tan squared is secant squared. And the antiderivative of secant squared is simply tangent. So the whole answer is tangent y plus c. So make sure you know the common trigonometric identities. So the first one that we mentioned, 1 plus tangent squared is secant squared. Make sure you know that. 1 plus cotangent squared is cosecant squared. Sine squared plus cosine squared is equal to 1. And sometimes you may or may not need the double angle formulas. Sine 2x is 2 sine x cosine x. Cosine 2x is cosine squared minus sine squared, which this is the same as 2 cosine squared minus 1, or you can write it as 1 minus 2 sine squared. So let's say if we wanted to find the antiderivative of 8 sine x cosine x, how would you do it? So 8, we can write it as 8. We can break it up as 4 times 2. And if you recall, 2 sine x cosine x is equal to sine 2x. So we have 4 times the antiderivative of sine 2x. And the antiderivative of sine is negative cosine. So this is going to be 4 times negative cosine 2x divided by the derivative of 2x, which is 2, plus c. So the final answer is negative 2 cosine 2x plus c. Let's try this one. What is the antiderivative of cosine x divided by 1 minus cosine squared? What would you do in this case? Now, if you recall, we said that sine squared plus cosine squared is equal to 1. So if we subtract both sides by cosine squared, we can see that sine squared is 1 minus cosine squared. So therefore, let's replace this expression with sine squared. So this is equal to cosine x divided by sine squared x dx. Now what would you do at this point? What do you think we should do? What is our next step? Now it might be helpful to split this expression and rewrite it. Sine squared is basically sine times sine. So cosine over sine squared is equivalent to cosine over sine times 1 over sine, since sine times sine is sine squared. Now cosine over sine is cotangent x. 1 over cosine is cosecant x. The antiderivative of cosecant cotangent is negative cosecant x. And so this is the answer. So make sure you know the common trigonometric identities, because you may find them to be useful. Now, what is the difference between these two expressions? Which one is a definite integral and which one is an indefinite integral? This expression is an indefinite integral. It's going to give you an answer in terms of x. In this case, x cubed over 3 plus c. This expression is a definite integral. It's going to give you a definite value. In this case, a finite value or a numerical number. So it's not going to give you a function in terms of x. So how can we evaluate this particular definite integral? It's important to understand the fundamental theorem of calculus. A part of it states this: the integration of f of x dx from a to b is equal to the antiderivative f of b minus f of a. Capital F is the antiderivative, or the integration of lowercase f. Just so you know, f prime of x is the derivative of f of x, and lowercase f is the derivative of capital F. Capital F is the integration or antiderivative of lowercase f, and lowercase f is the integration of f prime. So as you travel towards the right, it's integration or anti-differentiation, and as you move towards the left, it's differentiation, which is the process of finding the derivative. So make sure you understand the difference between those symbols. So whenever you see capital F, it's the antiderivative of lowercase f. So now let's evaluate the definite integral from 1 to 3. So first, find the antiderivative of x squared. It's x cubed over 3. Now you don't have to worry about the constant c, because when you perform f of b minus f of a, there's going to be two c values, and they're going to cancel. So you don't have to worry about the concept of integration. So now we're going to evaluate this from 1 to 3. So f of b, what that means is that we're going to plug in 3, which is b, into the antiderivative. So f of b, or f of 3, is 3 to the third power divided by 3 minus f of a. So we're going to plug in a, which is 1, into the antiderivative. So this is going to be 1 to the third power divided by 3. 3 to the third is 27. 1 to the third is 1. 27 minus 1 is 26. So the answer is 26 over 3. So let's work on some more examples. Try this one. feel free to pause the video. The antiderivative of x to the fourth is x to the fifth divided by 5. And we're going to evaluate it from 1 to 2. So we're going to plug in 1 first. The top one. We need to plug in 2 first. So it's going to be 2 to the fifth power divided by 5 minus, and then plug in 1. So 2 to the fifth power, that's 2 times 2 times 2 times 2 times 2, 5 times. That's 32. 1 to the fifth is simply 1. 32 minus 1 is 31. So it's 31 over 5. Now what about this example? What's the antiderivative from, or what's the value of the definite integral from 2 to 5? 3x minus 4 dx. So this is going to be 3x squared over 2 minus 4x evaluated from 2 to 5. So first, let's plug in 5. Let's find the value of capital F of b. So this is going to be 3 times 5 squared over 2 minus 4 times 5. And then minus, let's plug in 2. And now let's find the answer. 5 squared is 25 times 3. That's 75. 4 times 5 is 20. Don't forget to distribute the negative sign. 2 squared is 4. Divided by 2, that's 2 times 3 is 6. So it's going to be negative 6. Here we have negative 4 times 2, which is negative 8. With the negative symbol in front, that's going to be positive 8. So this is going to be 75 over 2. Negative 6 plus 8 is 2. Negative 20 plus 2 is negative 18. And negative 18 is the same as negative 36 over 2 if we multiply negative 18 by 2 over 2. 75 minus 36 is 39. So this is going to be 39 over 2, which is about 19.5. So that's the answer. Let's try one more definite integral problem. So let's say if this is 1 and e, and we wish to find the definite integral of 1 over x dx from 1 to e. So we know the antiderivative of 1 over x is ln x. So now we need to plug in b and a. So it's going to be ln of e minus the natural log of 1. What is the natural log of e? The natural log of e is always 1. The natural log of 1 is always 0. So the final answer is simply 1. Now sometimes you might not be able to evaluate the definite integral. For example, e to the x squared dx, let's say from 1 to 2, we can't integrate this function. However, we can approximate the value of a definite integral using Riemann sums. So how does that work? It turns out that, let's say if we wanted to integrate x squared from 0 to 8. This expression, the value of this definite integral, is equal to the area under the curve from 0 to 8. And using Riemann sum, we can use rectangles to approximate the area under the curve. So first, let's find the exact answer. To find the exact answer, integrate the function. So this is going to be x cubed over 3 from 0 to 8. So let's plug in 8 and let's plug in 0. 8 to the third is 512. And 0 raised to anything is just 0. 512 divided by 3 as a decimal is about 170.67. So let's use Riemann's sum to approximate this answer. So this is the exact area under the curve from 0 to 8. So let's use the left endpoints to get the answer. Using Riemann's sum, the area is going to be equal to delta x times the sum of f of x. So what we're going to do is we're going to break it up into rectangles. As you can see, you can approximate the area by adding up the area of each rectangle. Each rectangle has a width, delta x, times a height, f of x. So delta x, the width times the height, is going to give you the area of that rectangle. And to approximate the area from, let's say, A to B, you add up each rectangle, which is the sum of all the y values times the width, if the width is the same for each rectangle. So how do we apply this in a problem? What should we do? So first, we need to identify the function. Going back to the definite integral, the function f of x is x squared. Next, we need to calculate the width of the rectangle, or the width of each interval. Delta x is going to be b minus a over n. So we're going to approximate it using 4 rectangles, so n is 4. A is 0, b is 8. So therefore delta x is 8 minus 0 divided by 4, and so delta x is 2. So next, make a number line, starting from A, ending at B. So this is A, and this is B. Starting with A, add delta x to it. 0 plus 2 is 2, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. Now, using the left Riemann sum, you're going to choose 4 out of the 5 points. There's 5 points to choose from: 0, 2, 4, 6, and 8. And n is 4, so you can only choose 4 rectangles. So using the left Riemann sum, use the first 4 points on the left. So that's going to be 0, 2, 4, and 6. For the left Riemann sum, don't use 8. Now, if you have to find the area using the right Riemann sum, don't use the left point. Use the 4 points on the right. That's 2, 4, 6, 8. Now for the midpoint rule, use the points in the middle. That's 1, 3, 5, and 7. Alright, so let's make some space. So now let's calculate the area using the left Riemann sum. So delta x is the width of each subinterval, which is the width of the rectangle. That's 2. And then we're going to use the first 4 points on the left. So 0, 2, 4, 6. So it's going to be the sum of f of x, or the sum of all the y values. So that's f of 0 plus f of 2 plus f of 4 plus f of 6. Now f of 0, we know that f of x is x squared. So 0 squared is 0, 2 squared is 4, 4 squared is 16, 6 squared is 36. 4 plus 6 is 20, 20 plus 36 is 56. Times 2, that's 112. So the area using the left Riemann sum is 112. Now we know the exact area when we calculated the value of the definite integral was about 170.67. Notice that this approximation is not very great, and the reason for that is because n was small. N was 4. What's going to happen if we increase the value of n? If you increase the value of n, the answer is going to be better. It's going to be more accurate. By the way, this particular value, the left Riemann sum for this example, is it an underestimate or an overestimate? Because 112 is less than the actual area, 170.67, it's an under approximation or an underestimate. Anytime you have an increase in function, the left side has a lower y value than the right side. Therefore, the left Riemann sum is going to be an under approximation, and the right Riemann sum, or the Riemann sum using right endpoints, will be an over approximation. Now, if you have a function that's decreasing, the left side has a higher y value than the right side. So the left Riemann sum is going to be an over approximation, and the Riemann sum using right endpoints will be an under approximation. So now let's see what it's going to be if we use 8 instead of 4. So if n is 8, delta x is going to be 8 minus 0 divided by n, which is 8, and that's going to be 1. So in that case, the width of the interval is going to be 1. So we're going to have the points 1, 3, 5, and 7. So out of the 9 points that's on the board, we're going to choose the 8 points on the left. That's 0, 1, 2, 3, 4, 5, 6, and we're going to stop at 7. So the area is going to be delta x, which is 1, times f of 0, 0 squared is 0, f of 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. And we're going to stop there. So I'm going to use the calculator at this point. So 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. This adds up to 140. So 140 is still not very close to 170.6, but nevertheless, it's more accurate than 112. It's closer than 112 is. So as you can see, if you increase the n value, the approximations become more accurate. So that's how you can calculate using the left Riemann sum. Now what about the right Riemann sum? What's the answer? First, let's redraw the number line from 0 to 8. So using the right Riemann sum, delta x is still equal to 2 times the sum of all the f of x values. So we're going to use the 4 points on the right. That's 2, 4, 6, and 8. So it's going to be f of 2 plus f of 4 plus f of 6 plus f of 8. So f of 2, 2 squared is 4. 4 squared is 16. 6 squared is 36. 8 squared is 64. So now 4 plus 16 is 20. 36 plus 64 is 100. So we have 120 times 2, which is 240. So as you can see, this is an over approximation. The actual answer is 170.67. And since the function is increasing, the right side has a higher y value than the left side. And that's why the right Riemann sum is an over approximation. Now what's going to happen if we average the two values? Let's say if we take the left Riemann sum and we add it to the right Riemann sum divided by 2. So the left was 112, the right was 240, and 112 plus 240 is 352. 352 divided by 2 as a decimal. Let's see what that's going to be. That's 176. Notice that if you average the left and the right Riemann sum, you get a very good approximation of the area. 176 is very close to 170.6. But the average is still an over approximation, as you can see. Now what about the midpoint rule? What answer can we get using that? So using the midpoint rule, we're going to have to use the points 1, 3, 5, and 7. So it's still going to be delta x times the sum of all of the f of x values, or the y values. So delta x, the width is still 2. The difference between 1 and 3 is still 2, and between 3 and 5 is still 2. So the width of every rectangle is still 2, and then it's going to be f of 1 plus f of 3 plus f of 5. We're going to stop at 7. So 1 squared is equal to 1, 3 squared is 9, 5 squared is 25, 7 squared is 49. So 1 plus 9 is 10, plus 25, that's 35. 35 plus 49 is 84. And 2 times 84 is 168. Notice that the midpoint rule is a very good approximation. 168 is very close to 170.67. But nevertheless, in this example, the midpoint rule is an under approximation. Now the next thing we're going to talk about is the trapezoidal rule. So we're going to use the same number line from 0 to 8. So notice that for the left Riemann sum and the right Riemann sum and the midpoint rule, we use 4 of the 5 points that we see here. But for the trapezoidal rule, we're going to use all 5 points. But let me go over the equation. So the definite integral from a to b f of x dx can be approximated using the trapezoidal rule. It's going to be delta x divided by 2 times, and I should probably put this somewhere else. I'm going to need more space. Times f of x 0 plus 2 f of x 1 plus 2 times f of x n minus 1 plus f of x n. So what does that mean? For the y values, the first and the last one, multiply it by 1. Everything else in the middle, multiply by 2. X to the n is the last one. X to the n minus 1 is the second to last one. So let me show you how to use it. So we're still using 4 rectangles. A is still 0, B is still 8. So delta x is 8 minus 0 divided by 4. So delta x is 2. So for the trapezoidal rule, using 4 rectangles, it's going to be delta x divided by 2 times, we're going to use all 5 points, so 0, 2, 4, 6, and 8. So it's going to be f of 0 plus 2 times f of 2 plus 2 times f of 4 plus 2 times f of 6 and then plus f of 8. So the first and the last point do not multiply by 2, but everything in the middle will multiply by 2. So 2 divided by 2 is 1. F of 0, 0 squared is 0. And then f of 2, 2 squared is 4 times 2, that's 8. 4 squared is 16 times 2 is 32. 6 squared is 36 times 2, that's 72, and 8 squared is 64. We're not going to multiply that by 2. So 8 plus 32 is 40. 40 plus 72 is 112 plus 64. This is equal to 176. Notice that we calculated this answer before. This is equal to the average of the left and the right Riemann sum. It turns out that the trapezoidal rule is equal to the average of the left and right Riemann sum. You can prove it too. So the left Riemann sum was equal to delta x, for this particular example, times f of 0 plus f of 2 plus f of 4 plus f of 6. And the right Riemann sum was equal to delta x times f of 2 plus f of 4 plus f of 6 plus f of 8. And all of this is divided by 2, but we'll divide it by 2 later. So notice that we have 2 f of 2's, 2 f of 4's, and 2 f of 6. So therefore, if we combine like terms, it's going to be delta x times, there's only one f of 0, there's 2 f of 2's, so it's 2 times f of 2. There's 2 f of 4's. And there's 2 f of 6. And there's only 1 f of 8. And all of this is divided by 2, which you can put the 2 over here. And now you have the equation of the trapezoidal rule. So the trapezoidal rule is simply the average of the left and the right Riemann sum. Now there's one more rule that we're going to go over, and it's the Simpson's rule. So according to the Simpson's rule, it's going to be delta x divided by 3 times f of x 0 plus 4 times f of x 1 plus 2 times f of x 2 plus 4 times f of x n minus 1 plus f of x n. So according to the Simpson's rule, you're going to use all 5 points, like the trapezoidal rule. But the first and last point is going to have a coefficient of 1. The second and the second to last point is going to have a coefficient of 4. And then everything in between is going to alternate between 4 and 2. So let's use the Simpson's rule in this example. Delta x is still 2. So it's going to be delta x divided by 3 instead of divided by 2. And then it's going to be f of 0 plus 4 times the value of f of 2 plus 2 times the value of f of 4 plus 4 times the value of f of 6. So you have to alternate between 4 and 2. And the last one is just f of 8. So 0 squared is 0, 2 squared is 4, but times 4, that's 16. 4 squared is 16 times 2 is 32. 6 squared is 36 times 4, that's 144. 8 squared is 64. So now if we add 16 plus 32 plus 144 plus 64, that's 256. So this is 256 times 2/3. 256 times 2 is 512. So the answer is 512 divided by 3, which is about 170.67. So by coincidence, we got the exact answer. But the Simpson's rule and the trapezoidal rule and the midpoint rule are very good approximations of the actual area under the curve. But as we've seen, as n increases, the accuracy increases. The approximation becomes very close to the actual answer. So what if n keep on increasing? Let's say if n goes to infinity. As n approaches infinity, the approximation becomes equal to the exact answer. Now let's see how we can get the exact answer using limits. So the area is equal to the limit as n approaches infinity of the sum of the area of each rectangle. So that's going to be the sum of f of x, which I'm going to write as fci. So fci basically is the height of the rectangle times delta x, which is the width of the rectangle. So f times delta x is the area of the rectangle, and we're going to sum up all the area of each rectangle, starting from 1 to n, where n approaches infinity. So this is the area expression using the limit definition. So we're going to find the value of this integral from 0 to 8 x squared dx. So f of x is x squared, and we could find delta x. Let's begin by finding delta x, which is b minus a over n. b is 8, a is 0, and n, we don't have a value for it. N approaches infinity, so we need to leave delta x in terms of n. So delta x is 8 divided by n. Next, we need to find out what this value is, ci. ci helps you to find the location of each rectangle on the x-axis. For instance, if we draw the number line from 0 to 8, we're going to have these points. Now ci, you can define it based on the left endpoint or the right endpoint. ci is basically equal to a plus delta x times I. We know delta x is 2 in this example where n is 4. When n is 4, we have 0, 2, 4, 6, and 8. So the width of each rectangle is 2. A is the first number. A is 0. So let's say if I is equal to 0. So C0 is A, which is 0, plus delta x, which is 2, times I, which is 0. That gives us the first point of 0. Now what about C1? Well, A is still going to be 0, plus delta x, which is 2, I is 1. 2 times 1 gives us the second point, which is 2. Now let's say if I is 3. So C sub 3 is going to be A, which is 0, plus delta x, which is 2, times I, which is 3. 2 times 3 will give us this point, 6. So as you can see, this expression C sub I gives you the x value where the rectangle are located. So when I is 0, we get 0. When I is 1, we get 2. When I is 2, we get 4. When I is 3, we get 6. And so forth. So now let's continue. So we said delta x is 8 over n in terms of n. And ci is a plus delta x times I. A is 0 in this particular example. Delta x is 8 over n, and then times I. So ci is 8i over n. So this is the first these are the first two things that you need to do. You need to find delta x and ci. So now we can say that the area is equal to the limit as n approaches infinity from 1 to n, and this is going to be ci is 8I over n, delta x is 8 divided by n. F of x is x squared, so we need to take 8I over n and plug it in to this expression. So that's going to be 8I squared, which is 64I squared, divided by n squared, times 8 divided by n. 64 times 8 is 512. So we're going to have the limit as n approaches infinity I squared times 512, and we had an n squared on the bottom, and there was another n because it was 64 over n squared times 8 over n. So n squared times n is going to be n to the third. So this is what we now have. Now we need to take a little detour. There's 4 equations that you need to know. The summation of a constant c, starting from 1 to n, is equal to Cn. Make sure you write down these formulas, by the way. Now let's say this was I. The formula would then be n plus 1 over 2. Now the next one that you need to know is I cube, which is n times n plus 1 divided by 2 squared. And then the one that we need to know in this example is I squared. And that's equal to n times n plus 1 times 2n plus 1 divided by 6. So let's talk about how to use that expression. Let's say if we want to find the sum starting from, okay, this is not supposed to be n, that's supposed to be a 1. Let's say starting from 1 but stopping at 5 for I squared. What this means is that we're going to plug in 1 and we're going to add up every term stopping at 5. So the first term is 1. So it's going to be 1 squared plus 2 squared plus 3 squared plus 4 squared. And we stop when I is 5, when I reaches n. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. 1 plus 9 is 10, 4 plus 16 is 20, so that's 30 plus 25. So everything adds up to 55. Now the formula can help you to get the same answer. Let's say if n is 100, you don't want to have to add it 100 times. So the formula becomes convenient. So in the last example, n was 5. So n plus 1, 5 plus 1 is 6. 2n plus 1, 5 times 2 is 10, plus 1, that's 11. So we can cancel a 6. And what we have left over is 5 times 11, which gives us the same answer, 55. But now how do we apply the formula when calculating the area in this particular example? So once you get to this part of the problem, you want to replace the term I squared with an expression in terms of n. So as you mentioned before, this expression, the summation of I squared, is n plus 1, 2n plus 1 over 6. So we're going to replace this portion with this expression. And once you replace the I squared with n plus 1, 2n plus 1 over 6, the sigma notation expression disappears. So what we now have is the limit as n approaches infinity. So this is gone. And it's going to be n plus 1 times 2n plus 1 divided by 6 times 512 over n cubed. 512 and 6 are divisible by 2. If we divide 512 by 2, it's going to be 256. Half of 6 is 3. And we can cancel an n variable. So it's going to be times n plus 1 times 2n plus 1 over n squared. Now let's distribute n plus 1 and 2n plus 1. If we FOIL those two things, we're going to have 256 over 3 times 2n squared, that's n times 2n, and then we have n times 1, which is n, plus 1 times 2n, that's n plus 2n, which is 3n, and then the last term, 1 times 1 is 1, over n squared. Now what's going to happen when n becomes very large? When n approaches infinity, the terms 3n and 1 are insignificant to 2n squared. If you replace n with 1,000, 3n is 3,000, but 2n squared is 2 million. 2 million plus 3,000 is still about 2 million. So then this expression reduces to 256 over 3 times 2n squared over n squared, which n squared cancels out and reduces to 2. 256 times 2 is 512. So you get 512 over 3, which is 170.67, which is the exact answer. So that's how you can calculate the area under a curve using the limit definition. You can also evaluate the definite integral using this process. It's a long process, but this is how you do it. Now sometimes you may need to show a graph of the rectangles. Let's talk about how to graph the rectangles using the left, right, and the midpoint rule. But let's use the example that we had, which is y equals x squared from 0 to 8. So let's say this is the curve. So this is 0, 2, 4, 6, 8. So n is 4 in this example. And let's graph it using the left endpoints first. So for the left endpoints, we're going to use 0, 2, 4, and 6. So plot those points on the curve. And then when you draw your rectangle, draw a line to the right of each point. And then draw the rectangles. So we know the actual answer was 170.67, but using the left Riemann sum, we got an answer of 112. And we could see why it's 112. Notice that the rectangles are below the curve. There's a lot of empty space here. And that's why the approximation was an under approximation. Now how can we draw the rectangles for the right Riemann sum? So what you want to do is plug in the points on the curve. So the points we're going to use are 2, 4, 6, and 8. Now this time, draw a line to the left of the point. And then form the rectangles. notice that it's an over approximation. The rectangles extend above the curve. Now, for the right Riemann sum, we got an answer that was 240. It was an over approximation. We can see that there's a lot of space above the curves. Now, what about the midpoint rule? So we're going to use the points 1, 3, 5, and 7. So plot those points on the curve and draw a rectangle. Now when you draw your rectangle, you're going to draw a line towards the right and towards the left. So half of it is on the right side, half of it is on the left side. And then form the rectangles. Now the reason why this is a good approximation is because that in some areas you have the rectangle being below the curve, and in other areas the rectangle is above the curve, and so it's balanced and you get a better approximation. Now you know how to draw the rectangles for the Riemann sum using the left endpoints, right endpoints, and the midpoints. Let's try this problem. The data table below shows the velocity of an object at different times. What is the total distance traveled by the ball? The displacement traveled by the ball is equal to the integral of the velocity function from a to b. In this case, from 0 to 10. Now, distance and displacement will be the same if the object moves in one direction, if it doesn't change direction. So notice that the velocity is always positive. It doesn't become negative. So if the ball moves in one direction, you can calculate the distance by finding the displacement. They're going to be the same. If I move 8 meters to the right, the distance that I travel is 8 meters, and my displacement is still positive 8. But now if I travel, let's say, 5 meters to the left, my displacement is positive 8 minus 5, which is plus 3. I started at 0 and I ended at 3. But the total distance I traveled is 8 plus 5, which is 13. So displacement and distance are only different if you change direction. If you're traveling in one direction, these two are the same. So we can calculate the total distance using this formula. But that formula is actually equal to the displacement, just so you know. Now let's estimate the distance traveled using the left Riemann sum, the right Riemann sum, and also the trapezoidal rule. So let's start with the left Riemann sum. So we can see the width of each rectangle differs by 2. The time changes by 2 seconds. So delta x is 2. Now we need to add up the y values, in this case, the velocity values. Now for the left Riemann sum, we're going to choose every point on the left except the last point on the right. So that's the first 5 points. So that's a v of 0, which is 15, plus v of 2, which is 18, plus v of 4, and v of 6, and v of 8. And we'll stop here. So now let's add up the 5 values. 15 plus 18 plus 20 plus 21 plus 20, that's equal to 94 times 2. So this is going to be 188. So that's the area using the left Riemann sum. Now using the right Riemann sum, it's going to be 2 times all the values on the right side. So we're going to use these 5 values except the first one. So v of 2 is 18, v of 4 is 20, and then 21, and then 20 plus 17. So that's going to be 18 plus 20 plus 21 plus 20 plus 17, that's 96, times 2, that's 192. So both answers are very close to each other. Now, to use the trapezoidal rule, we can actually use the formula, or we can average the left and right Riemann sum. So if we add up 188 plus 192 and divide it by 2, we're going to get the midpoint of 188 and 192. The middle number is 190. 188 plus 192 is 380. Divided by 2, you get 190. But now let's do it the other way too, using the trapezoidal formula. So it's delta x, which is 2, divided by 2, times, now for the trapezoidal rule, we're going to use all points. So the first point, v of 0 is 15, plus 2 times the second point, which is 18, plus 2 times the next point, which is 20, plus 2 times 21, plus 2 times 20, and finally plus 27. So 2 over 2 is 1. This is going to be 15. 2 times 18 is 36. 2 times 20 is 40. And then 42 plus 40 plus 27. So if you add up these numbers, okay, this is not supposed to be 27. It's supposed to be 17. And the sum is going to be 190. So you get the same answer. So we can say the total distance traveled by the ball is 190. It's 188 on the low side, 192 on the high side, but it averages to 190. So here's a similar problem. We need to find the total distance, and we're given the time and the velocity. The velocity is in meters per second, the time is in seconds, which means the distance is going to be in meters. But notice that the width of each rectangle is not the same. Between the first 2 points, the width is 3. Between the next 2 points, it's 2, and it changes. So how can we calculate the area of this velocity time graph using the left Riemann sums, right, and the trapezoidal rule if the width of the intervals are not the same? So we're still going to take the width of each interval, delta x, and multiply by f of x. But in this case, it's going to be f of x1 plus delta x times f of x2 plus delta x times f of x3. We can't write it like this. The reason being is delta x is not the same. So we have to calculate delta x for each rectangle separately, since it differs. And that's the important thing that you want to take from this. So for the first rectangle, the width is 3. Now, if we're using the left Riemann sum, should we use the 23 or the 26? So you want to use the y value on the left side. That is 23. Now for the next rectangle, between 3 and 5, the width is 2. So between those two y values, we're going to choose the point on the left, which is 26. Now for the next rectangle, between 5 and 9, delta x is 4, or delta t. And between 5 and 9, we're going to choose the next point on the left, which is 22. After that, between 9 and 12, the width is 3, and we're going to choose 24. And then between 12 and 14, delta t is 2. We're going to choose 25. So we're going to choose all of the y values except 30. So for the last one, between 14 and 18, delta t is 4, and we're going to use 26. So let's go ahead and get the answer. So 3 times 23 is 69, 2 times 26 is 52, 4 times 22 is 88, 3 times 24, that's 72, 2 times 25 is 50, 4 times 26 is 104. So let's go ahead and add these numbers. So this is 435 using the left Riemann sum. So now let's get the answer using the right Riemann sum. So for the right Riemann sum, we're going to choose all of the y values except 23. So the width for the first rectangle is still 3, but we're going to multiply it by 26 instead of 23. Now for the second part, it's 2 times 22, and for the third part, it's going to be 4, and we're going to use 24. After that, between 9 and 12, it's 3, and we're going to use 25. And then between 12 and 14, it's 2, and we're going to use 26. And for the last part, between 14 and 18, it's 4 times 30. So 3 times 26, that's 78. 2 times 22 is 44. 4 times 24 is 96. And then we're going to have 75 plus 52 plus 120. So this is equal to 465. Now, how can we apply the trapezoidal rule if we have an uneven interval? What do we need to do here? So what we're going to do is we're going to multiply the width times the average of the two y values associated with that width. So this is going to be f of x0 plus f of x1 divided by 2. And then it's going to be plus delta x times f of x1 plus f of x2 divided by 2. And then we're going to repeat the process. So for the first point, the width of the interval is 3, and we're going to average 23 and 26. So initially I'm going to write it out. So it's 3 times 23 plus 26 divided by 2. Now for the next part, between 3 and 5, we're going to average 26 and 22. So the difference between 3 and 5 is 2, and then we're going to add up 26 plus 22 and divide it by 2. And then for the next part, between 5 and 9, the width is 4, and the two y values are 22 and 24. So we're going to add those two and divide it by 2. So between 9 and 12, that's a change of 3. We're going to average 24 and 25. And between 12 and 14, we're going to use 25 and 26. So 12 to 14 differs by 2. Then it's going to be 25 plus 26 divided by 2. And for the last part, between 14 and 18, we're going to average 26 and 30. So the difference between 18 and 14 is 4. And then it's going to be 26 plus 30 divided by 2. So let's start with the first one. 23 plus 26 is 49 divided by 2, that's 24.5 times 3. So that's going to be 73.5. The average of 26 and 22 is the midpoint, which is 24. If you add them up, you get 48 divided by 2, that's 24, times 2, that's 48. The average of 22 and 24 is 23. 23 times 4 is 92. The average of 24 and 25, the midpoint, is 24.5. Times 3, that's 73.5. And the midpoint of 25 and 26 is 25.5 times 2, which is 51. The midpoint of 26 and 30 is 28 times 4. That's 112. Now let's add up these numbers. Let's make some space first. So if you add up these 6 numbers, you're going to get 450. Now let's check to see if our work is correct. Let's average these two values. $435 plus 465 is 900. 900 divided by 2 is 450. So this is the area using the trapezoidal rule. The area of a velocity time graph represents the displacement. So the displacement of the ball is 450 meters. And since the ball is moving in the same direction, the velocity is never negative, it never changes direction. The total distance traveled by the ball is also 450 meters. Now that's it for Riemann sums and trapezoidal rule. Let's move on to a different topic. Let's talk about properties of definite integrals. So let's say if the integral from 1 to 4 f of x dx is 7, and the integral from 1 to 4 g of x dx is 9. What is 3 times the integral from 1 to 4 f of x dx plus 5 times the integral 1 to 4 gx dx, given these two values? To find the answer, you simply need to plug in. It's going to be 3 times 7 plus 5 times 9. So that's 21 plus 45, which is 66. And so that's all you got to do there. Now, what is the value of the definite integral from 4 to 1 f of x dx? What's going to happen if we reverse the numbers? If you reverse them, it's no longer going to be positive 7, but it's going to be negative 7. For instance, 4 minus 1 is 3, but 1 minus 4 is negative 3. So the only thing that happens is the sign is going to change. Now what is the integral from 4 to 4 f of x dx? If these two are the same, then it's going to be 0. F of 4 minus f of 4 is equal to 0. Now let's say that the integral from 1 to 3 f of x dx is 5, and the integral from 3 to 6 f of x dx, let's say it's 9. So what is the integral from 1 to 6 f of x dx? The integral from 1 to 6 is the sum of the integral from 1 to 3 plus the integral from 3 to 6. One way to understand this, let's say if you have a graph from 1 to 6. Let's say this is the curve. The integral from 1 to 3 is 5. The integral from 3 to 6 is 9. So from 1 to 6, it's simply the sum of these two values. It's going to be 5 plus 9, which is 14. So knowing that, let's say if the integral from 1 to 4, f of x dx, let's say it's equal to -7, and the integral from 1 to 8, f of x dx, let's say it's -13. What is the value of this expression from 8 to 4, f of x dx times -5? Feel free to pause the video and find the value of this expression. So first, let's write an equation. So from 1 to 4 plus from 4 to 8 has to add up to the total from 1 to 8. Now the area from 1 to 4 is -7, and from 1 to 8 is -13. In order to find the value from 8 to 4, we got to find the area from 4 to 8 first. So let's call it x. Solving for x, we need to add 7 to both sides. -13 plus 7 is -6, which is the value of this expression. So the integral from 4 to 8, f of x dx, is -6. Therefore, if from 4 to 8 it's -6, then from 8 to 4 it's going to be +6. Multiplied by -5, the final answer is -30. What is the value of this expression? How can we figure out the answer? To understand what to do in this situation, you need to know what this equation represents. X squared plus y squared equals r squared. This is an equation of a circle with radius r. If you solve for y squared is r squared minus x squared. And if you take the square root, y is plus or minus the square root r squared minus x squared, which is what we have here. So therefore, we can see that r squared is 16, which means we have a circle with a radius of 4. So let's go ahead and graph the circle. Now, which portion of the circle do we have? We know it varies from -4 to 4. Do we have the upper half of the circle or the bottom half? Because there's a positive sign in front, we have the upper portion of the circle. If there was a negative sign, it would be the lower portion. Now at this point, we don't know the techniques needed in order to integrate this expression. So what you need to do is use geometry to find the area. The area of a circle is pi r squared. So for a semicircle, it's 1/2 pi r squared. And r is 4. So it's 1/2 times pi times 4 squared. 4 squared is 16, divided by 2 is 8. So the answer is 8 pi. Let's try some more examples. What is the integral from 0 to 5 square root 25 minus x squared dx. So first, let's graph a circle. So we can see that r squared is 25, which means that the radius is 5. Now we only want the right side of the graph. That's from 0 to 5. And because there's a positive sign, we want to find the area of this quarter circle. So the area of that quarter of the circle is 1/4 pi r squared. R squared is 25, so the final answer is 25 pi over 4. Try this one. So let's graph the circle. So we need to integrate it from -6 to 0. And because there's a negative sign, we have the lower part of the circle. Now, it's still 1/4 of the circle. So it's going to be 1/4 pi r squared. And we can see that the radius is 6, which means r squared is 36. 36 divided by 4 is 9. So the area of the shaded region is 9 pi. However, the value of the integral is negative. It's negative 9 pi. Anytime it's below the axis, the integral will give you a negative value. If it's below the x-axis, that is. What about this one? What's the value of the integral from -7 to 7, negative square root 49 minus x squared? So it's going to be from -7 to 7, and it's going to be below the x-axis. So we have a semicircle. So the area is going to be 1/2 pi r squared. R squared is 49, so it's going to be 49 pi over 2. But the value of the integral is negative 49 pi over 2. Now what about this one? Let's say if it's plus or minus. What's the answer in this case? So what is the area and what is the value of the whole integral? So from -8 to 8, it's positive and it's negative. So we have the entire circle. The area of the entire circle is pi r squared. And r squared is 64, so it's 64 pi. But what about the value of the integral? The upper half part of the circle is positive 32 pi. The bottom part is negative 32 pi. So the value of the integral is going to be 0. It's going to cancel the positive side and the negative side. So it adds up to 0. So let's work on a few more examples, finding an area using geometric figures. So what is the value of this integral from 0 to 4? 12 minus 3x. So we're going to find the answer two different ways. First, let's calculate the value of the definite integral. So this is going to be 12x minus 3x squared divided by 2 from 0 to 4. So first we're going to plug in 4. So it's going to be 12 times 4 minus 3 times 4 squared divided by 2. And if we plug in 0, the entire thing is 0. 12 times 4 is 48. 4 squared is 16. Divided by 2, that's 8. 8 times 3 is 24. And 48 minus 24 is 24. So the value of the definite integral is 24. Now let's go ahead and graph the function. So if we have the graph y is equal to negative 3x plus 12, we can see that the y-intercept is 12. The x-intercept, if you replace y with 0 and solve for x is going to be 4. So we have the point 4 comma 0 and 0 comma 12. So now let's graph it. Now we wish to find the value of the integral from 0 to 4. So that's basically this region. But we can calculate the area of the shaded region by using the area of the triangle. The area of a triangle is 1/2 base times height. The base is 4. The height is 12. So it's 1/2 times 4 times 12. Half of 4 is 2. 2 times 12 is 24. And so you get the same answer. So let's work on some more examples. Calculate the value of this integral, 2x plus 3 from 1 to 4. And also use geometry to confirm your answer. So this is going to be 2x squared divided by 2 plus 3x. And we can cancel these. So it's x squared plus 3x. So if we plug in 4, it's going to be 4 squared plus 3 times 4. And if we plug in 1, it's 1 squared plus 3 times 1. 4 squared is 16. 3 times 4 is 12. 1 plus 3 is 4, so minus 4 because of the negative sign. 12 plus 16 is 28. 28 minus 4 is 24. So let's confirm the answer with geometry. So now let's graph the function, but we're not going to graph the entire function. We're only going to graph the portion between 1 and 4. When x is 1, what is the value of y? If we plug in 1 into the expression, 2 times 1 plus 3, we're going to get 5. So let's say 5 is somewhere over here. We don't need an exact graph. We just need an approximation. If we plug in 4, 2 times 4 is 8 plus 3, that's 11. So when x is 1, y is 5. When x is 4, y is 11. So what we need is the area of this region. That is the entire area, bounded from 1 to 4, between the x-axis and the line, or the curve. So to calculate the area using geometry, we need to break it up into a rectangle and a triangle. So let's focus on the rectangle. The rectangle has a length of 3. The difference between 1 and 4 is 3. And the rectangle has a height of 5. 3 times 5 is 15. Now let's focus on the triangle. The triangle has a height of 6. The difference between 11 and 5 is 6. Now the base of the triangle is still 3. So using the formula, area is 1/2 base times height. So it's 1/2 times 6, which is 3, times 3. So that's going to be 9. If you write out, it's 1/2, 3 times 6. 6 times 3 is 18, half of 18 is 9. And then if we add 9 and 15, that's going to give us 24. So you get the same answer. Now what about this one? What is the value of the definite integral from 1 to 6? Let's say if we have an absolute value expression. What should we do in this particular case? First, you need to find out the vertex of the absolute value. To find the vertex, set the inside equal to 0 and solve for x. So it's at 3. Now what you need to do is separate the function into two parts, from 1 to 3 and from 3 to 6. Now let's graph this expression. This graph has been shifted 3 units to the right. The absolute value function is basically a V shape. Notice that the right side, the equation for the right side is x minus 3. It has a positive slope. For the left side, it has a negative slope. It turns out that the left side has the equation negative x minus 3. So whenever you have an absolute value function or expression, you can break it up into two smaller equations. So in terms of a piecewise function, it's going to be x minus 3 and negative x minus 3. It's negative x minus 3 when x is less than 3, and it's positive x minus 3 when x is greater than 3. So from 1 to 3, we need to use negative x minus 3. And from 3 to 6, we need to use positive x minus 3. So the integration of negative x is negative x squared over 2, if you distribute the negative sign. And then for positive 3, it's going to become positive 3x, evaluated from 1 to 3. Now for the second part, it's going to be x squared over 2 minus 3x, from 3 to 6. So now let's plug in the values. 3 squared is 9, so it's going to be negative 9 over 2, and 3 times 3 is 9, minus, now let's plug in 1, it's going to be negative 1/2, plus 3. Now let's focus on this integral. 6 squared is 36 divided by 2, that's 18. 3 times 6 is also 18. Now if we plug in 3 squared is 9, so we have 9 over 2. And 3 times 3 is also 9. So we have negative 9 over 2 plus 9. Let's distribute the negative sign. So it's going to be plus 1 over 2 minus 3. These two cancel. And then negative 9 over 2 plus 9. Negative 9 over 2 plus negative 9 over 2 is negative 18 over 2, which becomes negative 9, which can cancel with this 9. So all we have left over is, so this is gone, 1/2. Negative 3 plus 9 is positive 6. So we have 6.5, or 6.5. So now let's get the area using geometry. So when x is 3, y is 0. When x is 1, 1 minus 3 is negative 2. The absolute value of negative 2 is 2. And when x is 6, 6 minus 3 is 3, so y is going to be 3. So what we need to do is find the area of the shaded region. So let's start with the triangle on the left. It has a base of 2 and a height of 2. So area is 1/2 base times height. 2 times 2 is 4, times a half is 2. Now for the other side, we can see the base is 3 and the height is 2. 3 times, actually the height is not 2, it's 3. This should be over here. I graphed it a little bit too low. If we plug in 6, y is 3. So it's 3 times 3, which is 9, times a half, that's 9 over 2, or 4.5. 2 plus 4.5 is 6.5. So we get the same answer. Now what is the integration of 5 dx? evaluated from 1 to 6. We know it's going to be 5x, and if we plug in 6, it's 5 times 6 minus 5 times 1. That's 30 minus 5, so the answer is 25. But how can we confirm the answer using geometry? How can we get 25? So first, we need to graph the expression y is equal to 5, starting from 1 and stopping at 6. So this is basically a horizontal line, and we could turn it into a rectangle. The area of a rectangle is just the length times the width. The length is 5. The width is also 5. 5 times 5 is 25. So basically this is a square. It doesn't look like a square, but it's not drawn to scale. Now what about this one? Negative 3 to 3 square root 9 minus x squared plus 7 dx. How can we find the value of this integral? So basically we have a circle that has been shifted 7 units up. And because there's a positive in front of the square root, we know it's the upper semicircle. So typically, this semicircle would be here, from negative 3 to 3, starting from the x-axis. Now, it's been shifted 7 units above the x-axis. So this is 7. So what we need to do is find the area of the shaded region, which is everything between the curve and the x-axis. So we need to split it into a rectangle and a semicircle. So this portion is a rectangle. As you can see, it has a height of 7 and the length of 6. The difference between 3 and negative 3 is 6. So 7 times 6, that's 42. And then the area of the semicircle is 1/2 pi r squared. We can see that r squared is 9, so it's 9 pi over 2. So the final answer is 9 pi over 2 plus 42. Using the graph on the upper right, what is the value of the integral negative 4 to 0 f of x dx? So from negative 4 to 0, we're looking for the area of this region, which is a quarter of a circle. So it's going to be 1/4 pi r squared, and we can see that the radius is 4. 4 squared is 16 divided by 4, so the area of that shaded region is 4 pi, which is the value of the definite integral. Now let's try another problem. What is the value of this integral? Let's say from negative 8 to negative 4 f of x dx, where this function is f of x. So from negative 4 to 8, we're looking for the area of the triangle. The area of that triangle, it has a base of 4 and it has a height of 5. 4 times 5 is 20. Half of 20 is 10. So this is going to be negative 10. Since it's below the x-axis. Now what is the value of the integral from 7 to 4 f of x dx? So the numbers are backwards. We need to find the integral from 4 to 7 first. So from 4 to 7, we see that the base of the triangle differs by 3, and the height is 8. 3 times 8 is 24. Half of 24 is 12. And so it's positive 12. Now we need to change the answer. From 4 to 7, it's positive 12. Therefore, from 7 to 4, it's going to be the opposite, negative 12. So always watch out for that. Now, what is the value of the integral from negative 8 to 12, f of x dx? So this is going to be everything. So we have the area of this triangle, which is 12, and this one is negative 10. Now here we have a rectangle with a length of 5 and a height of 8. So the area of the rectangle is 40. Now, for the semicircle, it's 1/2 pi r squared. R is 4. So 16, half of that is 8 pi. So this is going to be negative 10. And then for this whole region from negative 4 to 4, that's 8 pi. This answer was 4 pi. So this must be 4 pi as well, which adds up to 8 pi. And then 12 plus 40 is 52. 52 and negative 10, that's 42. So the entire answer is 42 plus 8 pi. Sometimes you might see problems known as initial condition problems. For example, let's say if f prime of x is 2x plus 5 and f of 0 is equal to 4. With this information, you could find f of x. If you're given an initial value or point, you need to use that point to find the value of c. So let's integrate this expression. F of x is going to be the antiderivative of f prime of x. So the antiderivative of 2x plus 5 is x squared plus 5x plus c. So f of x is equal to this expression. So now our goal is to find the value of c. So we're going to replace f of x with 4 and x with 0. So 4 is equal to 0 squared plus 5 times 0 plus c. So we can see that c is 4. So therefore f of x is x squared plus 5x plus 4. And so that's how you could find a function f of x given f prime and a point. Now what if you're given the second derivative? Let's say it's 4x minus 3. And f prime of 1 is 2, and f of 2, let's say, is 4. So you got to find f of x, which means we need to integrate the function 2 times. So let's integrate it the first time to get f prime of x. F prime of x is the integral of f double prime. So the antiderivative of 4x minus 3 dx, that's going to be 4x squared divided by 2, which is 2x squared, minus 3x plus c. So this is the function f prime of x, which means we need to use the point 1, 2 to find a value of c. So let's replace f prime of x with 2, and let's plug in 1 into the equation. So it's going to be 2 times 1 squared, which is 2, minus 3 times 1 plus c. So these 2 can cancel if we subtract both sides by 2. And if we add 3, we can see that c is equal to 3. So therefore, f prime of x is equal to 2x squared minus 3x plus 3. Now we need to find f of x, so we got to integrate this function. So this is going to be 2x cubed divided by 3 minus 3x squared over 2 plus 3x plus c. So now let's use this point to find the value of c. So f of x is 4, x is 2. 2 to the third power is 8 times 2, that's 16 over 3. And 2 squared is 4 divided by 2, that's 2 times 3, that's negative 6, plus 3 times 2, which is 6, plus c. So these two cancel. And at this point, let's go ahead and multiply everything by 3, just to get rid of the fraction. 4 times 3 is 12. 3 times 16 over 3 is just 16. And then 3 times c. So negative 4 is equal to 3c. So c is negative 4 over 3. Which means that the original function f of x is 2 over 3 x cubed minus 3 over 2 x squared plus 3x, and then minus the constant c, which is negative 4/3. So this is f of x. That's how you find it. Now you can apply the principles learned in the initial condition problems for particle motion problems. So let's say the acceleration of a particle, let's say it's 3t minus 6, everywhere where t is greater than 0. Now let's say that v of 1 is 3 and s of 0 is 1. With this information, find the velocity function and the position function. So what you need to know is that the velocity function is the integration of the acceleration function, is the antiderivative. And the position function can be found by integrating the velocity function. So let's find the velocity function first. So we need to integrate 3t minus 6, which is going to be, let's not forget the dt expression. This is 3t squared over 2 minus 6t plus c. So now let's solve for c. So by the way, this is v of t. So the whole thing is going to be equal to 3, and we're going to replace t with 1. So this is going to be 3 over 2 minus 6 plus c. Now if we add 6 to both sides, we're going to have 9 is equal to 3 over 2 plus c. And now let's multiply both sides by 2. 9 times 2 is 18. 3 over 2 times 2 is 3. And then 2c. So 18 minus 3 is 15. And so c is 15 divided by 2. So now we have the velocity function. So v of t is therefore 3 over 2 t squared minus 6t plus 15 over 2. So now we can find the position function, which is the integration of the velocity function. So it's 3 over 2 t to the third power divided by 3 minus 6t squared divided by 2 plus 15 over 2t plus a new constant. You can use c again. Some textbooks call the second constant d. So we use d instead of c, since c is 15 over 2. Now we can cancel these, and this reduces to 3. So now let's use this. So s is 1, and t is 0. So 0 minus 0 plus 0 plus d. So we can see that d is 1. So therefore the position function s of t is going to be t to the third minus 3t squared plus 15 over 2t plus 1. Now let's say if you're given the velocity function. Let's say it's 2t minus 6. And you want to find the displacement and the total distance traveled by a particle represented by this function, let's say from 0 to 5. How can we do it? Well, if you wish to find the displacement given velocity, simply integrate the velocity function from a to b. So we need to integrate it from 0 to 5 to t minus 6 dt. So the antiderivative of 2t is t squared. So it's going to be t squared minus 6t from 0 to 5. So if we plug in 5 squared is 25, 6 times 5 is 30, minus 0. So the displacement is negative 5. Now how can we calculate the total distance traveled? In order to find the total distance traveled, you need to find out where it changes direction. That's the first thing you should do. The particle changes direction when the velocity is 0. So we need to set 2t minus 6 equal to 0. If we take out a 2, we can see that when t is 3, v is 0. So v of 3 is 0. Now that we have this point, we need to calculate the displacement between 0 and 3 and 3 and 5. Now keep in mind, distance is always positive. So if we get a negative answer, we're going to make it positive. So we know this is going to be t squared minus 6t. So we have to evaluate it from 0 to 3 and 3 to 5. Let's plug in what we have. 3 squared is 9, 6 times 3 is 18, and then minus 0. 9 minus 18 is negative 9. So we need to take the absolute value of negative 9. So it travels 9 units in the first 3 seconds. Now for the next 2 seconds, if we plug in 5 squared is 25, 6 times 5 is negative 30, and then minus 3 squared is 9, 6 times 3 is 18. 25 minus 30 is negative 5. 9 minus 18 is negative 9. So this is negative 5 plus 9, which is 4. So the total distance is 9 plus 4, which is 13. In the last example, we got a displacement of negative 5. Now let's understand why. So let's draw a number line. So let's assume that we started from 0. The first answer was negative 9. So the particle traveled 9 units to the left. And then the second answer was positive 4. So it traveled 4 units to the right. When you add negative 9 and 4, you can see that the displacement is 5. Negative 5 though. Negative 9 plus 4 is negative 5. So its final position is at negative 5. The change in position, final minus initial, negative 5 minus 0, is negative 5. So by adding these two values, you can get the displacement. To get the distance, you need to make the negative value positive. So it's 9 plus 4. The total distance is 13, but the displacement is negative 5. So whenever you wish to calculate the distance, you need to convert any negative displacements into positive values, and then add everything, and you should get the answer. Although you might have seen some of these things when you learned derivatives, it's good to review it. So let's review some basics of particle motion. Whenever the acceleration is positive, the velocity is increasing. Whenever the acceleration is negative, the velocity is decreasing. And whenever the acceleration is 0, the velocity is constant. The particle is speeding up whenever velocity and acceleration have the same signs. Either they're both positive or they're both negative. The particle is slowing down whenever acceleration and velocity have opposite signs. It could be positive and negative or negative and positive. The particle is moving to the right whenever the velocity is positive, and it's moving to the left whenever the velocity is negative. And it's at rest, or it could be changing directions, when the velocity is 0. So those are a few things to keep in mind. And if you have a graph, let's say a graph of position versus time. Let's say the position is y and time is t. Actually, let's just use s. The slope of the position time graph will give you the velocity. That's the only thing you need to worry about for a position time graph. Now for a velocity time graph, the slope of a velocity time graph gives you the acceleration. Now the area is equal to the displacement, so that the area is the displacement of the particle. And lastly, for an acceleration time graph, all you need to be concerned with is the area. The area of an acceleration time graph is equal to the change in velocity. That is equal to the final velocity minus the initial velocity. Now let's review the fundamental theorem of calculus. There's two parts. The first part basically states that the integral from a to b f of x dx is equal to f of b minus f of a, which is associated with the net change theorem. So that's one part of the fundamental theorem of calculus. Another part states that if you take the derivative of the integral of a function, let's say this is f of t, you're going to get f of x. And it makes sense. If you integrate lowercase f, you get capital F. And if you differentiate capital F, you get lowercase f. So we're going to focus on questions of this type. You know how to apply this information because you've done this before when evaluating a definite integral. So let's focus on the one below. So for example, let's say if we wish to find the derivative of the integral from 1 to x square root 1 plus t squared. It's not that easy to integrate the square root of 1 plus t squared. So how can we do this? Well, you don't want to integrate the function and differentiate it because some functions are just too difficult to integrate. It turns out that the answer is simply the square root of 1 plus x squared. Keep in mind this is f of t, and according to the fundamental theorem of calculus, this should give us f of x. So basically you just got to replace t with x. But some problems are not easy as this one. For example, what if we change it? Instead of x, what if it's x squared? What's going to happen now? So I'm going to show you two ways to get the answer. The fast way and a way if you wish to show work. So the first thing you need to do is replace t with x squared. So it's going to be 1 plus x squared, which is t, and then squared. The next thing you need to do is multiply this expression by the derivative of x squared. The derivative of x squared is 2x. So the answer is this. It's 2x square root 1 plus x to the fourth. So how can we show our work to get that answer? So first, we're going to say that square root 1 plus t squared is f of t. So we're looking for the derivative of the integral of f of t dt. The antiderivative of lowercase f is capital F. So this is going to be capital F of t evaluated from 1 to x squared. So now we're going to use basically the other portion of the fundamental theorem of calculus, where this is going to be f of b minus f of a. So we have the derivative of f of b minus f of a. So the derivative of big F is little f. So this is going to be lowercase f of x squared. And according to the chain rule, we need to differentiate the nested function, or the function on the inside. The derivative of x squared is 2x. F of 1 is a constant. The derivative of any constant is 0. So now, if f of t is the square root of 1 plus t squared, f of x squared is the square root of 1 plus x squared squared. And it's multiplied by 2x. So that's the answer. So that's how you can show the work if you want to. But now let's work on some more examples. So using the fast technique, go ahead and calculate the value of this expression in terms of x. So step 1, replace t with x cubed. So it's 1 plus x cubed raised to the third power. Step 2, differentiate x cubed. The derivative of x cubed is 3x squared. And so this is going to be the answer. It's 3x squared times the square root of 1 plus x to the ninth. Now what about this one? Let's say if the x squared is on the bottom. And let's say it's square root 1 plus t to the fourth. So once again, we're going to replace t with x squared. And multiply by the derivative of x squared, which is 2x. But because it's on the bottom, there's going to be a minus sign in front of it. So when you integrate the function, it's going to be f of 3 minus f of x squared. And when you differentiate f of 3, that's going to disappear. But this negative sign will be attached to the f of x squared part. And so here it is. Now what if you have something that looks like this? Let's say x squared, 2x cubed, 1 plus t squared. Actually, let's use a different function. Let's use the natural log of t. So keep in mind there's two parts. You're going to have f of x cubed minus f of x squared. So for the first part, replace t with x cubed. So it's going to be ln x cubed. And then find the derivative of x cubed, which is 3x squared. And so we're going to put that in here. And then minus. Now we need to work on this example. Let's replace t with x squared. And the derivative of x squared is 2x. So let's put that in the front. This is going to be the answer. Now let's prove it. So we're going to say f of t is ln t. So the integral of lowercase f is capital F. And now we're going to plug in these values. So it's f of x cubed minus f of x squared Oh, let's not forget the derivative. Very important. It's supposed to be there. I just forgot to write it. So the derivative of this expression is going to be lowercase f times x cubed, and then times the derivative of the inside, which is 3x squared. And then for this one, it's going to be minus f of x squared times the derivative of x squared, which is 2x. And we said that f of t is ln t. So this is ln x cubed, and then minus 2x ln x squared. And so you get the same answer. So that is it for this video. That's all I got, so thanks for watching and have a great day.